Question 1. In the context of machine learning model evaluation, which metric measures the proportion of times actual positive instances that were correctly identified by the model? Option A, accuracy. Option B, precision. Option C, recall. Option D, F1 score. The correct answer is recall. Here's the explanation. Recall, also known as sensitivity or true positive rate, is defined as TP plus fluorine mononitride, representing the proportion of all actual positive instances that the model correctly identified. Question 2. A machine learning model is being developed for a cloud security system to detect highly critical but rare zero-day exploits. The primary concern is to ensure that no actual exploits are missed, even if it means a higher number of false alarms. Which evaluation metric should be prioritized for this model? Option A, accuracy. Option B, precision. Option C, recall. Option D, specificity. The correct answer is recall. Here's the explanation. Recall should be prioritized when the cost of a false negative, missing an actual exploit, is high. Ensuring no actual exploits are missed directly relates to maximizing recall. Question 3. A binary classification model achieved 98% accuracy in detecting a rare event that occurs in only 0.5% of cases. Why might relying solely on this accuracy metric be misleading for evaluating the model's effectiveness? Option A, accuracy does not account for the model's training time. Option B, high accuracy can be achieved by simply predicting the majority class for imbalanced datasets. Option C, accuracy is only relevant for regression models, not classification. Option D, the model's recall must also be 98% for it to be effective. The correct answer is high accuracy can be achieved by simply predicting the majority class for imbalanced datasets. Here's the explanation. For imbalanced datasets, a model that always predicts the majority class, e.g., no event, can achieve high accuracy while being useless at detecting the rare positive event. This is a common pitfall when relying solely on accuracy. Question 4. In a binary classification confusion matrix, what does A, false positive, FP, represent? Option A, the model correctly predicted the positive class. Option B, the model correctly predicted the negative class. Option C, the model incorrectly predicted the positive class when the actual class was negative. Option D, the model incorrectly predicted the negative class when the actual class was positive. The correct answer is, quote, the model incorrectly predicted the positive class when the actual class was negative. Here's the explanation. The study material defines false positive, FP, as this represents the number of instances where the model incorrectly predicted the positive class. The model made a KUA false alarm. For example, if the model predicted an email was spam, but it was actually not spam. Question 5. A cloud-based fraud detection system flags transactions as fraudulent, positive, or legitimate, negative. The business prioritizes minimizing financial losses from actual fraud, even if it means inconveniencing some legitimate customers. Which type of error is the most costly in this scenario, and which metric should be prioritized for optimization? Option A, false positive, FP, precision. Option B, false negative, FN, recall. Option C, true negative, TN, accuracy. Option D, true positive, TP, F1 score. The correct answer is false negative, FN, recall. Here's the explanation. If the business prioritizes minimizing financial losses from actual fraud, they want to avoid missing true fraudulent transactions. A false negative, FN, occurs when an actual fraudulent transaction is predicted as legitimate, leading to financial loss. To minimize FNs, the model's ability to identify all actual positive cases, fraud, should be maximized, which is measured by recall, TP plus fluorine mononitride. Question 6. Given the following confusion matrix for a binary classification model, calculate the recall sensitivity for the positive class. Actual positive, actual negative. Dash 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 dash. Predicted positive, 90 TP. Predicted negative, 5 FN, 95 TN. Option A, 0.90. Option B, 0.95. Option C, 0.50. Option D, 0.83. The correct answer is 0.95. Here's the explanation. Recall is calculated as TP plus fluorine mononitride. In this matrix, true positives, TP equals 90, and false negatives, FN equals 5. Therefore, recall equals 90 plus 5 equals 90/95, approximately equals 0.947, which rounds to 0.95. Question 7. What is the primary goal of adopting responsible AI (RAI) principles in the development and deployment of AI systems? Option A. To maximize the computational efficiency of AI models. Option B. To ensure AI systems are developed and used ethically, fairly, and safely. Option C. To exclusively focus on achieving higher model accuracy metrics. Option D. To reduce the overall cost of AI infrastructure. The correct answer is to ensure AI systems are developed and used ethically, fairly, and safely. Here's the explanation. Responsible AI principles provide a framework for ethical, transparent, accountable, and fair development, deployment, and management of AI systems, aiming to mitigate potential harms and build trust. Question 8. A company is developing an AI model for employee performance evaluation. To ensure that the model does not inadvertently disadvantage certain demographic groups, they rigorously analyze the training data for disparities and implement techniques to balance representation. Which responsible AI principle are they primarily upholding? Option A. Transparency and explainability. Option B. Privacy and security. Option C. Fairness and equity. Option D. Robustness and reliability. The correct answer is fairness and equity. Here's the explanation. Fairness and equity ensure that AI systems treat all individuals and groups equitably, without perpetuating or amplifying existing societal biases. Analyzing and mitigating bias in data directly addresses this principle. Question 9. An organization uses a cloud-based AI service that provides tools to visualize and quantify the influence of different input features on an AI model's specific predictions. This capability primarily supports which responsible AI principle? Option A. Accountability and governance. Option B. Transparency and explainability. Option C. Societal and environmental benefit. Option D. Human centricity and human oversight. The correct answer is transparency and explainability. Here's the explanation. Tools that help visualize and quantify feature influence on predictions are key components of explainable AI, XAI, which directly contributes to the transparency and explainability principle by making model decisions comprehensible to humans. Thanks for watching. Please subscribe to my channel.